Okay, so some people were asking questions about the quiz, so I thought I'd do some similar examples since I didn't do a practice quiz, which maybe I should have, but hopefully this helps out. It's basically the same thing as practice quiz. Okay, so first one, you start off with absolute value of x, and now we're going to graph then, starting with this, what does this look like? So we do all this crazy stuff for the absolute value of x, and what would this graph look like? In other words, how would different points on this graph shift? So first step when you do these is you got to get the x by itself. We have a 4x. So we rewrite our g of x as 2, take out the 4x plus, and 4 times 1/4. You always divide by whatever you're multiplying it by, minus 3. Then you always check 4 times x is 4x, 4 times 1/4 is plus 1/4. Okay, yep, looks good. Then you write your steps, the multi-part rule, or your order of operations, whatever you want to call it. What do you do to this graph to get this one? And the first thing you always do, and you just kind of got to memorize this order, because maybe you want to take away 3 from the y first, but it does make a difference to the order. First thing you do is you do the dilation in the x direction. In this case, it's compression. If you multiply by 4, it makes it 4 times skinnier. X direction is always opposite. So in the x direction makes it 4 times skinnier. That's the same thing as multiplying by a fourth. That's what you do. You multiply the x value by a fourth. Okay, then you shift in the x direction. Plus 1/4 is 1/4. You'd think it goes to the right, positive, but it's always the opposite. It goes to the left. So then we shift to the left 1/4. So you shift the x value to the left 1/4. Now we're done with x's, because remember our function is the absolute value of x, so it's what's inside. Now we do the outside, which is the y. Y is like 2 times the x. So the third step is if we multiply the y by 2, that actually does make the 2 dilate, 2 times bigger. The y direction makes sense. We stretch it by 2 or dilate it by 2. And the fourth step is the minus 3, and again that means we shift it down 3, right? Take away 3. Again, the y direction makes sense. So that's our order of operations. So then part B says what happens to the point 1, 1. No, that's not part B, that's just the second part of this, right? So anyway, so what happens to the point 1, 1? As an example, so if we're going to compress the points, or shift and change the points, where would the point 1, 1 from our original function, because y equals x, if x is 1, y is 1, right? So that is a point on the original graph. How would that look like on this one? Where would that point go on this graph? So the first thing is you compress the x by 4. So 1 becomes 1/4. The y stays the same. We haven't done anything to the y. Then we take away 1/4. 1/4 to the left, which makes it 0. 1/4 minus 1/4 is 0. Now we do the y. We make the y twice as big. So it becomes 2. And then we shift it down 3, which means we take away from it. The x stays the same, negative 1. So that's what the point 1, 1 becomes. For the second one, it's pretty much the exact same thing. It's the exact same thing. You take the point, doesn't matter really, that's an x squared. You just do the same thing, the same kind of steps, no matter what the function is. I guess it matters it's x squared because that's our function, so anything outside the squared part does happens to the y, but it's the exact same way. If you can do number 1, you can do A, you can do B. Okay, number 2, that's where you start with a graph, which I graphed. Okay, so I'll make up another graph here. So let's say we have something that looks like, I don't know, looks like this or something. I'm just going to use straight lines because it's easiest. You don't have to try to match the curve, because straight lines are easy. Straight lines will always go to straight lines. So this curve is going to be, when we shift and do all the stuff to it, it's going to be straight. So you don't have to worry about trying to match a curve. Okay, now you can see it. Don't have to worry about trying to match a curve. So what are these points going to do on a new graph when it's shifted? Okay, so, and the way it's shifted, I'm going to make up a different one. Let's say it's 3f 2x plus 8 minus 2. Okay, so if this is f of x, what will this look like? Okay, well, we do the same thing. 3, we take out the x by itself, 2x plus 4 minus 2, 2 times x is 2x, 2 times 4 is 8, yep, that's right. First thing we do is dilate. So in the x direction, we make it twice, we compress it by 2, always the opposite, 2 times smaller, which means we multiply it by 1/2. The y then we shift it 4 left, so it goes 4 left. Then we, y direction, we multiply it by 3, which is what we'd think, makes it 3 wider. And in the x direction, in the y direction, we go down 2. It's really similar to my last example. Didn't mean it to be, just kind of worked out that way. Okay, so we take a point, so let's say, and I made the graph that I made, you can see what the points are, okay, I put numbers on it, you can tell every point. So what you gotta do is shift every point that's obvious on the graph that I made. Looks like there are 4 points, just like in mine here, you're gonna have 4 points to shift. So let's pretend that, let's start with this N1, let's say this was, looks to me like they're the same, so let's say it was -3, 3. So what's that new point going to look like? Where are we going to graph it in our new graph? So we would first, so we do the same thing, we write the point. You're going to have to do this 4 times, so I left lots of room. We do this 4 times, the -3 and the 3, then the next point, the next point, the next point. So let's just do 1 here and get the idea. So -3, 3. Y, x direction, multiply it by 1/2. So it becomes -3/2, 3. And then we take away 4 from the x. Oh, that's hard. That's 8/2, right? 4 is 8/2, so that'd be -11/2. I think I did that right. Multiply the y by 3. -11/2, 9. 3 times 3 is 9. And then shift the y 1, 2. That's -11/2. And down 2, so 7. So this point here goes to -11/2, which is -5.5. -5.5. So that would be, if this is -3, so maybe -5.5 is here, and 7. Y equals 7, so it'd be way the heck, that would be, okay, it's kind of off the graph here, but whatever. So somewhere up here, right? This would be, so that would be our new point. So this point here shifts to up there. And then we do it for the next one. And let's pretend the next one is right there. So then the graph would look like this, and maybe the next one is right here, it looks like that, the next one's down there. So that would be our new graph. You just shift each one of the points, figure out where it goes to, plot them, and then connect the dots. Okay. Hope that helps. Let me know if you have any other questions.